Ladies and gentlemen, we once again have our 6th hour blended honors geometry extraordinaire class. Woo woo! America, there you go. Very good, Grace.
Costco.
All right. Costco. We got trapezoids for today. A very exciting day indeed. First off, we want to add to our family tree here. We want to add to our family tree with all the exciting properties. Alrighty, so we have our family tree here, our properties of an isosceles trapezoid. That's where you get the most information. For a regular trapezoid, it's just one pair of opposite sides are parallel. Okay? Now, our bases of this trapezoid would be AB and CD. Those are the bases, and they are parallel. All right. Our legs are the ones that come down from those parallel bases, and those are congruent in an isosceles trapezoid, not necessarily in a regular trapezoid. If they were congruent, then it becomes an isosceles trapezoid. And you can see everything else down here. We've got our upper base angles are congruent, our lower base angles are congruent, our diagonals are congruent as well, and then any pair of upper base to lower base angles are supplementary to each other. Lovely. Moving on. Let's use them. Oh, geez. I need to get rid of that. Boom, gone. Ooh, fun. A proof. Let's skip that. Let's go to this bad boy here. All right, so I've got ABCD is an isosceles trapezoid. Find the measure of angle ABC. So we're looking for this angle right up here. I'll give you guys a moment to think about that, and then we'll go through. All right, if we got an isosceles trapezoid here, we know our bases are parallel. And what do we get from parallel lines? What kind of information can we get from parallel lines? Crickets, crickets. Angles, very good. We get congruent angles, supplementary angles, all sorts of dope information about angles. For example, this angle here and this angle down here, those are alternate interior angles. So that is 28 degrees as well. Now, what's lovely about an isosceles trapezoid is the same would apply over here. This is also going to be 28 degrees. All right? So everything's kind of, it's almost like it's a symmetrical down the middle. Like if you were folding it in half, all the information is the same on one side as it is the other because it is an isosceles trapezoid. Cool. So what does that mean for this angle right up here?
28.
It's also 28. Woo! I like it. It is congruent to this one right here. Awesome. Wonderful. I guess I'll make this one with 2 blue ones as well. Cool. What about our other angle? The other part of that angle. Is there a way to figure that out? Not supplementary to 28, or to something else.
It's supplementary to angle ABC.
Ah, so these two, these two angles are congruent. These two big angles are congruent, but the upper and lower base are supplementary, as Presley said. So we know what this angle is right here, right? What is that one? 75? So what does that mean for the angle ABC?
75.
Not 75. If ADC is 75, that's a lower base angle. It is then supplementary to the upper base angle. 105, 105. That would be my final answer there. So kind of work our way around and across and all over the place to this isosceles trapezoid. Again, if you fold it in half, it's basically they're symmetrical. The two halves of this are symmetrical to each other. So those angles are going to match up, which is just lovely. Okay. Oh boy. So this one right here, we got some importing issues with the floating segments and angles. But we'll do our best to work with it here. So we got AD is parallel to BC over here. And AC, which is a diagonal, and BD intersect at E. The measure of angle ABC is 130, and the measure of the other distances in centimeters and angles are marked. What is the length of the diagonal? AC. Now, this looks like a ton of stuff going on. It's crazy. Who knows what's going on? But it's a regular trapezoid. Lovely, lovely. What else can we go with here? Why don't we take a minute here to think about it? That sounds great. Alrighty, so one piece of information we might want to write down from the given is this angle right here being 130 degrees. And if we look right here, add those two up, we get 130. So my upper or my lower, whatever ones you want to call it, I guess lower in this case, even though it's kind of flipped upside down, those base angles are congruent, making it what type of trapezoid, children?
Isosceles.
Isosceles. What do I know about my diagonals of an isosceles triangle? They are congruent. So if I knew this diagonal right here, I could figure out my other diagonal right here. Well, what's 2 root 3 plus 6 root 3? 8 root 3. Yay! And that would be the measure of my diagonal, so that matches up to my other diagonal. I have my final answer. Lovely! So we have another lovely justification problem with coordinate geometry. We want to figure out what this is. Now, just at a glance and look at this one, any ideas of what it might be? A trapezoid. Does it look to be an isosceles trapezoid? No, it doesn't, but we still need to justify why it is or why it is not. Well, what do we know about the bases of a trapezoid? They must be parallel. So let me find my slope here. It looks like I'm going up 2 and over to the right, let's see, over to the right 11. So 2 over 11, is that right? I think that's right. That looks good. Awesome. And then let's see here, for D to C, looks like I'm going up 4 and over 22. So 4 over 22 would equal 2 over 11. So what do I know about my upper and lower base? They are parallel. They have the same slope. That's good. That's a start for a trapezoid. It's either a trapezoid or an isosceles. Well, what differentiates it from being a trapezoid to an isosceles trapezoid? Jake?
The two outside are congruent.
Yes. So this is a case where I end up needing to find the length of both of these, and yes, I have to use distance formula. Wah. So let's see here. AD, that's going to be, let's see here, the square root of, let's see, A and D would be -9 minus -10. So -9 plus 10 is 1 squared plus, let's see here, 1 minus -6, which is 7 squared. So I've got 1 plus 49 is square root of 50. Okay. I'm not even going to simplify it right now. If I need to in the end, I will. And then I got BC. So let's see here. This one would be 12 minus 2 is 10 squared. And then we've got -2 minus 3 is -5 squared. So I've got 100 plus 25 square root of 125. Again, I'm not even simplifying them because all I'm doing is comparing. Are they the same or not? Are these two legs the same length? No. So it's just a trapezoid. Woo woo! Awesome. America, freedom, rock and roll. YOLO.